Okay, today you're going to learn how to solve absolute value inequalities, and open your textbook to page 45. Okay, so on the top of your notes, let's write solving absolute value inequalities. Okay. Now, before I actually start this, let's look at this. My question is, what makes this true? Okay, 3x is greater than 15. You're used to looking at, based on the previous lessons, 3x equals 15. Okay, so maybe start here. Okay, what value of x makes this true? Okay, what value of x makes this true? Think about it. Well, you see that 3 times 5 is 15, so x must equal 5. Okay, so we say the equation has one solution. Okay, one solution. Notice this is not an equation. We call this an inequality. Okay, notice not equation, but rather inequality. My question is, what makes this true? Think about it. 3x is greater than, we read this as 3x is greater than 15. Okay, so if you think, does 5 make it true? That's the first question. Does 5 make it true? Well, my question is 3 times 5 is greater than 15. Is 15 greater than 15? Well, hopefully you say 15 is not greater than 15, so we see that 5 does not make this true. Okay? But what values of x would make this true? Would 6 work? Is 3 times 6 greater than 15? Hopefully you say yes. 18 is greater than 15. Okay, so we see that 6 works. What else works? What else works? Maybe 7. 3 times what? 3 times 7. Is this greater than 15? Yes. Okay, so we get 21 is greater than 15. Absolutely. Okay, so we see 6 works. 7 works. What else would work? Hopefully you can see that, well, 8 would work. 9 would work. Okay. So we see here, let's put a number line. Call this the x-axis. Here's 5. Did 5 work? No. Okay. 5 did not work because 15 is not greater than 15. So we put an open circle. Open circle means 5 is not a number that makes this true. Okay. Does 6 work? Yes, 6 works. So we're going to put a closed dot. Does 7 work? Yes, 7 works. We're going to put a closed dot. And my question is, does 6.1 work? Does 6.1 work? Yes. Is 3 times 6.1 greater than 15? Absolutely. Okay, we get 18.3. This is greater than 15. Okay. Does 6 points, we're going to put, this is 6.1. Okay, does 6.2 work? Yes. Does 6.3 work? Yes. Okay. Does 5.1 work? Hopefully you say yes. 3 times 5.1 is greater than 15. Because we end up with 15.3, which is greater than 15. So 5.1 works. Does 5.01 work? Does 5.1 right here? Does 5.1 work? Yes. Does 5.01 work? Yes. Does 5.001 work? Yes. Does 5.0001 work? Yes. When would we stop? Okay. Hopefully you say never. Okay. 5.00001 work. Okay, does 5.100 zeros and then a 1, does this work? Yes. Okay, so anything just slightly greater than 5 works. Okay, does 5.2 work? Yes. Does 5.02 work? Yes. Does 5.002 work? Yes. How many numbers make this true? How many numbers make this true? Hopefully you say a whole lot of numbers. Okay, many, many numbers. In fact, we say infinitely many solutions. Infinitely many solutions, meaning that there are infinitely many numbers that make this true, beyond your comprehension. Hopefully, wow is going through your mind right now. Wow. Okay, so we need to get out of thinking in terms of 6, 7, 8, but we need to start realizing, okay, are there a lot of numbers between 6 and 7? Yes. Are there a lot of numbers between 5 and 6? Yes. Okay, beyond your comprehension. In fact, there's as many numbers between 5 and 6 as there are all real numbers, okay? And we're going to talk more about this, but you start to notice we're going to see that all of these points work, okay? Infinitely many points stacked infinitely close together form what? a solid line. Okay, so we're going to put array, okay, meaning that this represents all numbers that are greater than 5. Okay, so what makes this true? What makes this true? Hopefully you say all numbers that are greater than 5. Not 5, but everything to the right of 5. Okay, now, with the equations, we had one solution. Okay, I showed you examples of equations that had 2 solutions. I also showed you examples of equations that have no solution. But in this case, we have how many solutions? Infinitely many solutions. Now, let's look at some of the problems. What I'm going to show you is first how to do, and then I will show you why. Okay, so first, let's just look at what we need to do, and then I will go back and I will explain what's going on behind the scenes. Okay, so let's look at the first problem. Okay, this is an absolute value inequality. Absolute value of x minus 3 is greater than 5. Okay? All right, the first thing you need to put on your notes is less than or equal to means and. Okay? Greater than or equal to means or. Okay? Now, there's a trick to remembering this. I always tell students here, less than. Okay? Can you make an A out of this? Absolutely. Okay, use your imagination. All right, and I'm talking small a. So if you have A in the alphabet, not a capital A, but a small a. So let's do this again. Okay, if I write less than, can you make an A out of this? Yes. Okay, so use your imagination. Put a tail on it. It looks kind of like an A. Okay, look at less than or equal to. Less than or equal to. Can you make an A out of this? Yes. Okay, so you can put a tail on that and make an A. So this would be an example of an and statement. Just a trick to remember. This is your and, okay? And this, you cannot make an A out of this. So this is your or, okay? So greater than is or. So looking over here, my question is, can you make an A out of this? Hopefully you say no, okay? You cannot make an A out of this, so our connective word is going to be or. So I want you to write or. Okay, this is our connective word. Now, we're going to write 2 equations, very similar to what you did with the equality, okay? We're going to write, watch this, what's inside, x minus 3. Notice there are no absolute value bars. We write exactly what we see on the inside. X minus 3 is greater than 5. Notice that this looks exactly like this statement without absolute value, okay? Or, our second equation is going to be x minus 3. So notice the x minus 3 does not change. And now we're going to flip the signs. Notice it was greater than here. Now we're going to make it less than. Okay, and we're going to flip the sign. So I say flip the sign, flip the sign, flip the sign, flip the sign. So we have greater than is going to become less than. Positive 5 is going to become negative 5. Okay, so we end up with 2 equations. Now, what you have to do is just simply solve. Okay, so it's just like equality. If we draw a line down the center, move the negative 3 to the right, it becomes what? Positive 3. Cross it out. X is now greater than 8. Or, okay, draw a line down the center, move the negative 3, we have plus 3. Okay. X is less than negative 5 plus 3 is negative 2. Okay? All right, so this is your preliminary answer. Now what you have to do is you have to take the solution and put it into 3 different forms. Okay, so we're going to start with here. First is number line. So I want you to write number line on your paper. Make sure you're taking notes, okay, so that you don't have to rewind and rewatch and rewind and rewatch, but rather write it down, then you can just look at your notes. Number line, okay. We call this 8. Number 8 is called a critical value, so we're going to mark its location. Negative 2 is also a critical value. We're going to mark its location. Here's negative 2, and here's 8. Okay, now before we go any further, you also need to add this to your notes. Okay, less than, greater than is open. Okay, here, let me do this. Less than, greater than is open. Okay, which is parenthesis. Okay, less than or equal to, greater than or equal to is closed. Okay, and this is bracket. We'll talk more about what this means in a moment. But for right now, I need you to know less than, greater than, open. Okay, less than or equal to, greater than or equal to, closed. Again, I'm not concerned with you understanding right now, just seeing the process. Okay, I will go back and explain what all this means shortly. Okay, so starting with, so less than, greater than means what? Open. We look here. X is greater than 8. So we look at the sign. Is this open or closed? Well, hopefully you say open, so we're going to put an open circle above 8. And it means do not include 8 in the solution, okay? Less than or greater than here. I'm sorry. Open or closed, okay? Less than or greater than means what? Open. So at negative 2, we're going to be what? Open. Now, let me rewrite this. X is greater than 8 or x is less than negative 2. Now, the inequality sign always points to the smaller value. So if we look here, okay, what is it pointing towards? It's pointing towards 8. So 8 is your smaller value, and x is your larger value. So we read from x. We read x, since x is larger, we read x is greater than 8. Okay, the inequality sign points towards the smaller value. X is your smaller value, negative 2 is your larger value. So we read from x. X is smaller than negative 2. Let's start here. We read this as x is greater than 8. Okay, so looking here at your number line, greater than 8. If I say x is greater than 8, this is your x-axis, okay? Or it says your solutions are bigger than 8. Are we to the right of 8 or to the left of 8? Okay, so hopefully you say to the right. Bigger than 8 is to the right. Okay, and x is smaller than negative 2 would mean to the left of negative 2. Okay, so we're going to be here. Notice, your solution set has two pieces. Okay, now I'll explain what this means in a minute. Let's go to the next. Okay, this is inequality notation. Go ahead and write these words down as well, because you're going to have to know the difference between inequality notation and the next one that I'm going to write also starts with an I. Okay, inequality notation says this is a fancy way. This is a fancy way of saying this. Okay, so we're going to put a brace. Inequality notation, we're going to put a brace. Okay, it's on the keyboard of your computer. If you've never seen this before, this is called a brace here. Right, it looks like this. Okay, this is a brace. Okay, this is open brace. This is closed brace. Okay, so we're going to put a brace. And what's our variable? Variable was what? Variable was x. Okay, so we're going to say x, and then a line, meaning such that. Okay, x such that x is bigger than 8 or x is less than. So you're just rewriting this. Okay, so x is bigger than 8 or x is less than negative 2. Close the brace. Okay, so basically it's a fancy way. This here is a fancy way of writing what we originally had. Okay, next we're going to write interval notation. Interval notation, okay, notice these look very similar. Okay, so make sure you know the difference between inequality and interval. And above interval notation, I want you to write left to right. Left to right. Okay, so we're going to read the number line left to right. Okay? Now, notice that this goes on forever to the left. Forever to the left. Okay, so we're saying what values of x make this true. Okay? In words, we describe this as the numbers that are greater than 8 or the numbers that are less than negative 2. So the numbers smaller than negative 2 or the numbers bigger than 8 make the original statement true. For example, let's pick a number. Pick a number that's bigger than 8. Pick a number that's bigger than 8. 9. Okay, so 9 is bigger than 8. Let's see if this makes it true. 9 minus 3 is 6. Okay, the absolute value of 6 is 6. Is 6 greater than 5? Yes. Okay, so 9 makes it true. Pick another value way out here to the right. Way out here to the right. How about 100? Is 100 way out here to the right? Yes, let's try it. 100 minus 3 is 97. The absolute value of 97, is this greater than 5? Hopefully you say yes, so 100 makes it true. All of the values to the right of 8 make this true. Okay, now let's look at the numbers that are less than negative 2. Pick a value less than negative 2. Hopefully maybe, so maybe negative 5. Okay, try negative 5. Negative 5 is smaller than negative 2. Negative 5 minus 3 is negative 8. The absolute value of negative 8 is 8. Is that greater than 5? Yes. Okay, so we're going to pick even a smaller value. What's smaller than negative 5? Pick a smaller value, way down to the left. How about negative 100? Okay, so negative 100 minus 3 is negative 103. Okay, the absolute value of negative 103 is 103. Is that greater than 5? Hopefully you say yes. Okay, now notice, we don't have any solutions. This is empty in here. Okay, between negative 2 and 8, there are no solutions. The values, what this says is the values between negative 2 and 8 are not solutions. Let's try a number between. How about, what's a number between negative 2 and 8? How about 0? Okay, 0 is between negative 2 and 8. Let's try it. What is 0 minus 3? 0 minus 3 is negative 3. The absolute value of negative 3 is 3. Is 3 greater than 5? Hopefully you say no. Okay, so the numbers between are not going to work. Now, when we write the interval notation, what we want to do is start from the left and go to the right. So we're reading left to right. The problem is, where does this thing end? Okay, so my question, is negative 5 a solution? Yes. Is negative 100 a solution? Yes. Is negative 1,000 a solution? Yes. Is negative 1,000,000 a solution? Yes. And for forever and ever and ever to the left. What do we call this concept, forever to the left? Hopefully you can say, well, infinite, big, forever. Okay, it's something we cannot understand. We call this concept, forever to the left, the concept of negative infinity. So I want you to put a little, looks like a sideways 8. Okay, this means negative infinity. And to the right, what value is it to the right of 8? Well, my question is 100 a solution? Yes. Okay, so to the right of 8, is 100 a solution? Yes. Is 1,000 a solution? Yes. Okay, is 1,000,000 a solution? Yes. All the numbers to the right of 8 are solutions. And how do we say forever to the right of 8? Okay, so we call this concept positive infinity. I want you to put this, it looks like a sideways 8 again, okay, except without the negative sign, okay? Now, to read left to right, we say, integral notation says, okay, start from the left, go to the right. What numbers make this true? What numbers make the original statement true? Well, all the numbers from the concept or the idea of negative infinity up to what? Up to negative 2. So we're going to start, the concept start at. How do you start at negative infinity? It makes no sense. But from forever left up to what? Up to negative 2, comma, negative 2. Okay, now, always put parenthesis next to negative infinity. And now my question, at negative 2, are we open or closed? Open or closed? We are open. Okay, so notice, when we are open, what are we going to use? Parentheses. So I want you to put a parenthesis next to negative 2. Now, we have a break in the graph. Where does it start? It starts up again where? At 8. Okay, so at 8, are we open or closed? Hopefully you say open. Okay, and so we're going to start at 8. Okay, and since it's open, we're going to put what? Parenthesis next to 8. Up to what? Forever to the right. Forever to the right is positive infinity. Okay, so always parenthesis next to positive infinity or parenthesis next to negative infinity. We'll talk a little bit more about that in a minute. Now, you have two things. To join two things as one, we're going to use a union symbol. It looks like a U without a tail. Okay, so this means join two sets as one set. Okay. Now, I've told you there's two cases. You could either have or you could have and. Okay, so I'm going to show you an example of an and statement one more time through this process, and then on the next video I will talk about what all this means. Okay, so right now you're probably going, oh my gosh, this is way too much. Way too much. Just give it time. Okay, so right now, just try to understand the process of what we're doing. Okay, I will show you what it means, and then I will clear up confusion. Okay, so let's look at this one. Absolute value of x plus 7 is less than or equal to 1. Okay, now remember, less than or equal to. Can we make an a out of this? Yeah, hopefully you say yes. Use your imagination here. Put a tail on it. Put a tail on it. That's and. Okay, that's and. Greater than or equal to. Well, we can't make an a out of that, so we're going to call that or. All right. Now, looking at the equation or inequality, is this and or is this or? So, can we make an a out of this? Hopefully you say yes. We can make an a out of this. This is going to be an and statement. Now, just like on the last one, we're going to write two equations. The x plus 7 does not change. We're going to say x plus 7. Nothing changes on the first statement. Less than or equal to 1. Okay, and our connective word is what? And. Okay. On the next equation, the x plus 7 does not change, so we're going to write x plus 7. Okay. Now flip the sign, flip the sign, flip the sign, flip the sign. Since we had less than, we're now going to have what? Greater than. Okay. We had positive 1, we're going to flip that to negative 1. So flip the sign, flip the sign. Now we end up with two equations. What you have to do now is just simply solve them. Okay, so maybe pause the video for a moment and finish solving the equations. Alright, so we're going to move the 7 to the other side. It becomes what? Minus 7. We have x less than or equal to 1 minus 7 is negative 6. Okay, and move the 7 to the other side. It becomes what? Negative 7. Okay, cross it out. We have x is greater than or equal to, since the signs are the same, we add. This is negative 8. Okay. All right, now, and statements. Okay, with the or statement, we left it alone. And statements have to be, what we say, compressed. Okay, so we're going to say x. X is going to be between two values. And means between. We will talk about this in the next video. Again, for right now, just try to follow along. We're going to put x in the middle. We're going to put the larger value to the right, the smaller value to the left. What's our larger value? What's our larger value? Well, hopefully you can see that negative 6 is the larger value. Okay. And then negative 8 is the smaller value, so we're going to put that to the left. Now the signs always point in the same direction. They always point to the left. If you forget this, watch. Circle this. X is less than or equal to -6. We're going to write that. Less than or equal to -6. And the other one points the same direction. So notice. Do you see that the sign is pointing towards -8? Okay, it is still pointing towards -8. We read this as x is between -8 and 6, or the values that make this true, the numbers that make this true are the numbers that are between -8 and -6. Okay, now, same thing, we're going to represent our solution 3 ways. First, number line. Okay, so we're going to draw a number line. Where are the critical values? Hopefully you say the critical values are -8, -6. All right. Open or closed? Okay. Back. Remember, less than, greater than is open, parenthesis. Okay. Less than or equal to, greater than or equal to is closed, bracket. Okay. So we're going to say what? Closed at -8, closed at -6. So put a point solid above -8, and put a point solid above -6. Okay. So closed at -8, closed at -6. We read this as x is between -8 and -6, and we're going to connect these. Okay. So what this says are the numbers that make that true are the numbers that are between -8 and -6. Okay. Now, next, inequality notation. Inequality notation is a fancy way of saying this. Okay, so I'm going to rewrite this. X is between -8 and -6. Signs always point to the left. Okay, a fancy way of saying this. Maybe think of it like think it this way. You can put a brace. Okay, so simply put a brace. Put a brace. Okay, what's our variable? Variable's x. We're going to put our variable x in a line. This line represents the word such that. We read this as the set of all numbers x such that x follows this rule, or the rule that x must be between -8 and -8 and -6. So we're going to put a brace, variables x, such that x is between -8 and -6. Okay? Now, lastly, interval notation. Interval notation says what? Left to right. Okay? We read the solution set on the number line left to right. So starting at the left. Question, are the numbers below -8 solutions? Hopefully you say no. Are the numbers bigger than -6 solutions? Hopefully you say no. Let's show. Okay, let's pick a number. Here, I'll show you. Pick a number below -8. Something smaller than -8. How about -10? Is -10 smaller than -8? Yes. Let's put -10. -10 plus 7 is -3. The absolute value of -3 is 3. Is 3 less than 1? No. Okay, so -10 is not a solution. Pick a number larger than -6. Okay, something larger than -6. Is 0 larger than -? Yes, 0 would work. Okay, 0 is larger than -6. Let's try it. 0 plus 7 is 7. Okay, the absolute value of 7 is 7. And is 7 less than 1? Hopefully you say no. Okay, so notice, there's no region out here, there's no region out here. Where are we saying what solutions or what numbers make this true? The numbers that are between -8 and 6. That's what this solid line represents. Okay, so pick a number between -8 and -6. All of these numbers work. How about -7? Okay, -7 is between -8 and -6. If we put -7 in, -7 plus 7 is 0. Okay, the absolute value of 0 is 0. And is 0 less than -1? Okay, yes. Okay, so we see that -7 works. Okay. This works, and all of the numbers between -8 and -6 will work. Again, we will investigate this more in the next lesson. But for now, you understand this means the numbers that are between -8 and -6. Interval notation says read this left to right. So we're going to describe the solution set, or the numbers that make this true, by reading left to right. Starting where? Starting at -8. Okay? Starting from the left, nothing, nothing, nothing. Starts at -8, goes where? Up to what? Up to -6. Put a comma. Okay? From -8 to -6. Open or closed at -8, okay? Open or closed. You see that it is closed, we're going to use a bracket, okay? And open or closed at -6. You see that it is closed, so we're again going to use a bracket. Now, that concludes this video. This is introductory lesson. Hopefully, maybe rewind and rewatch the steps, okay? And the very next lesson, I will show you what all of this means, okay? All right.